So today we're going to be looking at number patterns. We are going to look at some challenging number pattern questions, but we're going to start with an easy question today. All right, let's do a quick recap of what we know. So in most of your exams, you will find that they will give you a formula. They will just give you the formula. That's all they'll do. They'll say Tn is equal to a plus n minus 1d, and Tn is equal to a times r to the power of n minus 1. Ooh. All right, but they're not going to tell you what any of these mean. You need to know exactly what these mean in order for you to use them effectively. So first thing we're going to note is that the first formula is for an arithmetic sequence. And this is something we need to know. We also need to know that Tn stands for the general term, A stands for the first term, so T1, N stands for the term number, and D stands for the common difference. Now, nobody's going to tell us this. We need to know this. We need to remember that the common difference can be calculated as T2 minus T1, or it must also be T3 minus T2. So both of them must line up in order for this to work. All right, in order for it to be called a common difference. All right, then in our next formula, we know the bottom formula is our geometric formula. Okay, and all of the things kind of stand for the same thing. A is also our first term, our T1. The only difference is that our R, instead of having a common difference, we will have a common ratio. All right, and remember when we calculate for the ratio, we will take T2 divided by T1, and that must be the same number that we get if we take T3 divided by T2. All right, so both of those must work out. All right, and we need to know all of this information. I just need to check quickly with you guys. Give me a thumbs up. Am I able to give you guys a number patterns question to try on your own without me helping you? Are we okay with that? I'm getting one thumbs up. I'm going to assume everybody else is also okay with it. I'm sorry, guys. I know that I'm sitting in the dark. It's because we have, I don't think it's load shedding. We just lose power every time there's rain. Okay, they're not hard, I promise. Okay, here are your 3 questions. I'm going to give you guys 5 minutes. And while you guys work on this question, on these 3 questions, I'm going to try and get rid of my hiccups. Okay. Did Dimalo ask, ma'am, how do you know how to use which formula, or can you use any? All right, so first you need to establish, Didimalo, whether it is arithmetic or geometric by figuring out whether it has a common difference or whether it has a common ratio. I'll scroll up a little bit just to remind you how we can determine these. Okay, so if it has a common difference, we can take term 2 minus term 1, and that must give me the same answer as term 3 minus term 2. So if that's the same number, then I know that it's a common difference and therefore it's arithmetic. But if I take term 2 divided by term 1, and that gives me the same number as term 3 divided by term 2, then we know that it's geometric and we can use the second formula. All right, does that answer your question? Okay, first figure out whether it has a common difference or whether it has a common ratio. Yes, Gift, you can use that. Tell me when you're done so I can scroll back. All right, excellent. I'm going to give you guys 2 more minutes and then we're going to look at this question. That's a good question, Arisha. He's normally the first one in the chat telling us about his day. Maybe he's taking the day off. All right. Okay, let's have a look at these questions. All right. So, like I said, first thing we're going to have to do is first establish whether these questions or this particular sequence is arithmetic or geometric. Now, in this case, we're going to have to go look, see if we have a common difference or whether we have a common ratio. We can see from this that we have a common difference of 10. So my T2, which is 28, minus 18 will give me 10. And I know that 38 minus 28 will also give me 10. So I have a common difference. So I know that in order to find the general formula for this, I have to use Tn is equal to A plus N minus 1 D. And I know that my D is 10. All right. And then all I'm going to do is substitute into the formula. I'm going to have Tn is equal to A, which is my first term, 18 plus open brackets N minus 1 multiplied by my common difference 10. And then we're going to distribute. I should get Tn is equal to 18 plus 10n minus 10. Therefore, Tn is equal to 10n plus 8. All right. 1 mark for using the correct formula and substituting into the right formula, 1 mark for the final answer. All right, so in the next question, it says, determine which term has the value of 248. Now, what this tells me is to replace the whole of Tn with 248. So we'll go 248 is equal to 10n plus 8. And then we're just going to solve for that. So I'm going to take 8, transpose it over to the other side, and I will end up with 248 minus 8. So that will give me 240 is equal to 10n. Then I will divide both sides by 10. Therefore, n is equal to 24. All right. 1 mark for substituting incorrectly, 1 mark for the final answer. All right. How did we do out of 4 for the first question? Yes? That's perfectly okay. Gift, even if you write 8 plus 10n, that's perfect, correct. Okay, lovely. Okay, so let's go look at C. Oh, Gift, where did we go wrong? Okay, even if you wrote 8 plus 10n, it's correct. All right. Okay, in this last question, it says, which term of the sequence 5, -5 over 2, 5 over 4 is the number -5 over 128? Now, this is a really tough question. I'll give you that. But first thing we need to do is first, as always, we're going to have to establish whether it's an arithmetic or whether it's a geometric sequence. Now, if I take these two things and I minus them from each other, -5 over 2 minus 5, that's going to give me -15 over 2. And if I take 5 over 4 minus -5 over 2, that's going to give me 15 over 4. And that is not a common difference. So I can't minus these two to find a common difference. So instead of minusing, I know that I'm not going to get a common difference. Let's look for a common ratio. So I know my ratio is going to be T2. So I'm going to take -5 over 2 divided by 5. And that's going to give me -1 over 2. And then I can take 5 over 4 divided by -5 over 2, and that will also give me -1 over 2. So I know from doing this calculation that I have a common ratio. I have an R of -1 over 2. All right, thumbs up. Everybody okay with that? Are we all good? Did we manage? Okay, Gift. I don't want to move on unless you understand that I've cleared up what that what is about. Are we okay with what ma'am has done here? Yes, you can punch these into a calculator and they'll give you the right answer. Okay, so remember, first we check for common difference. If we don't have a common difference, we check for common ratio. So now that we have a common ratio, we know that it's a geometric sequence, and therefore we can use the geometric sequence formula. All right, so I know I can use Tn is equal to A times R to the power of n minus 1. All right, so I can sub in all that they've given me. So this, they're telling me, is the Tn part. That's what I'm subbing in here. All right, so I'm going to get -5 over 128 is equal to our A value is 5 multiplied by, now remember guys, whenever we have a negative common ratio, you're going to leave it in the bracket. You do not take it out of the bracket, otherwise your n minus 1 part isn't going to do what it needs to do in terms of getting us the correct answer. Every answer is going to come out negative if we don't do that. All right, so now we're solving for n. We know that n is the thing that we're solving for. N is attached to the -1/2, so I can't separate them as yet. So the first thing I'm going to get rid of is the 5. So I know I'm going to have to divide this side by 5 and divide this side by 5. So I'm going to end up with -5 over 128 divided by 5 will give us -1 over 128, and that is equal to -1/2 to the power of n minus 1. All right, now I'm dealing with exponents. And the only way I can compare exponents is if I have the same what, grade 10s. What do I need in order to compare exponents? That's it, Sanele. Good. I need the same base. So I need to figure out how to take -1 over 128 and turn it into -1/2 something. So what first thing I'm going to do is I'm going to take this part over here. I'm going to take the 128 and I'm going to shift fact that into my calculator. And what it's going to do is it's going to give me 1 over 2 to the power of 7. All right, everybody okay with that? Yes, if I take 128 equals shift fact into my calculator, it will give me 2 to the power of 7. Now, I want you guys to be very honest with me. I'm about to do something a little weird. I can't yet, not yet, Narisha. I'm going to do this. I'm going to put 1 to the power of 7 like that. Thumbs up. Is everybody okay with that? Thumbs up if you're okay with why ma'am can do that. Thumbs down if I need to explain a little bit more. Okay, sorry guys, I'm just trying to keep in the loop as to what's happening with our electricity because I am sitting in the dark, guys. Okay, so let me do this. For those of us who are a little confused, let's do a simple exercise. And I know this is going to be redundant. We all know that 1 to the power of 1 is equal to just 1, right? But 1 to the power of 2 is also equal to 1. 1 to the power of 4 is also equal to 1. 1 to the power of 253 is also equal to 1. So it doesn't matter really what exponent I give the 1. 1 to the power of negative 655. My answer will still come out as 1. Does that make sense, Narisha? Yes? We all cool? Lovely. All right. So the reason why I want to do that is because, let's say, for instance, we have a question where we have 8, sorry, let me write it over here. Say 8 over 27. What I can do with 8 over 27 is I can rewrite this as 2 to the power of 3 over 3 to the power of 3. And as soon as these two things have the same exponent, I can take that exponent out as a common factor. So I can do this 2 over 3 to the power of 3. Okay. Everyone okay with that? Thumbs up? Yes? Are we all good? All right. Now, think about what ma'am has just said and see what I'm going to do over here. Do you see now how I've taken 2 to the power of 7 and I've taken my 1 and I've also written it as to the power of 7. So I know that I can take out that power of 7 as a common factor. Everybody okay with that? We're going to take it out as a common exponent. Lovely. So on this side, I'm going to end up with negative 1 over 2 to the power of 7 is equal to, and on this side, I will have negative 1 over 2 to the power of n minus 1. And now, Narisha, do you see what I'm seeing? Does everybody see what I'm seeing? Yes, I have the same base. Okay, I have the same base. Okay, Didimalo, which part am I re-explaining? That's it, Princess. Okay, everybody else continue. Didimalo, I don't want to leave you behind. Which part did I confuse you on a little bit? The substitution. Okay, all right. Okay, so let's look at this. Okay, do you understand? Just give me a thumbs up. Do you understand what ma'am has done here? The thing that I've just highlighted in red. Are we okay with that? No. Okay. All right. So there is a mathematical rule. We learn about it in exponents, right? That if I do this, let's say, for instance, they give us x to the power of 2 over y to the power of 3, all of this to the power of 4. Do we know what to do with that? Yes? We would distribute. Are you in agreement there with me? Yes? We would distribute, right? We would do this. We would go 4 times 2 and we'd go 4 times 3. And then we'd end up with x to the power of 8 over y to the power of 12. That's what would happen. Now, this particular idea can work in reverse. We can work it in reverse. So if they give me x to the power of 8 over y to the power of 12, I know that the highest common factor between 8 and 12 is 4. So I can take 4 out. I can go x to the power of 2 times 4 over y to the power of 3 times 4. And because they both have 4 in common, I can take 4 out. So I can end up with x squared over y cubed all to the power of 4. Do you see how I've done this thing in reverse, Didimalo? Does that make sense? Okay, lovely. All right. So if we think about that, right? If we think about that idea, I've now given you 1 over 128. Right. Now, if I take 128 and I shift fact, I'm going to end up with 1 over 2 to the power of 7. Right. Now, I want to take out a common factor, a common exponent that 1 and 2 would have in common. So what exponent can I put on the 1 in order to make it make sense so that I can take something out that's common between the two of them? What can I take out? Or what exponent do I want my 1 to have so that I can take out a common exponent? I'd want it to have a 7. Are we in agreement? Right? I would want this to be 7. And that doesn't change the value of the sum, because 1 to the power of 7 is just 1. It's not going to change anything. And now that they have the same exponent, I can take 7 out as a common factor. So I will have 1 over 2 to the power of 7. Because I know that if I want to, I can just distribute back in. All right. Does that make sense to you, Malo? Are we okay there? Lovely. All right. So let's go here. Now, if we go here, right, I've taken 128 and I've written it as 2 to the power of 7. I've chosen my 1 as 1 to the power of 7. So I can take 7 out as a common factor. And that's exactly what I've done. So I've taken that out. And inside, I've got 1 over 2 left, all of that to the power of 7. Okay. Lovely. And now that I have the same base, I can drop my bases. I can drop this base and I can drop this base. And what I will have left is 7 is equal to n minus 1. Then we can transpose the negative 1. Therefore, n will equal 8. Okay. And that is a 3-mark question because we've done exponents in grade 10 already. You will get 1 mark for substituting correctly, 1 mark for finding the same base, and 1 mark for the final answer. All right, no 6 marks, unfortunately, gift. We're only getting 3 marks for this particular question. Okay, let's quickly see. Thumbs up, thumbs down. How are we feeling about this question that we've just gone through? Okay, Sanele says thumbs up. Okay. All right, I want to challenge us a little bit. I don't want us to get stuck in the same space. I want us to do something a little bit more challenging today. All right, so we're going to go over to this question. We're not going to do the first question. It's too messy. Okay, we're not doing that one. So we're going to start here. This is question A. And where SIPO starts, that's question B. All right, so question A says here, consider the number pattern 1, 3, 1, 6, 1, 9, 1, 12, 1, ... Determine the 999th term and the 1000th term. Now, before we even pick up a pen or a pencil or a calculator, before we start panicking, let's think about this. Look at what they've given you. I can 100% guarantee you, everybody can tell me what the 999th term is. Are we able to tell Teacher Coco what it is? Just by looking at what's happened in that sequence they've given us. That's it, Narisha. Beautiful. Everybody understanding why the answer is 1? Yes, this is more of a logic question than anything, really. Okay, Princess, let's have a look at the sequence, right? That's it, Narisha, that's correct. Let's have a look at the sequence. If we look here, we see the first term is 1. T1 is 1. T2 is 3. T3 is 1. T4 is 6. T5 is 1. T6 is 9. T7 is 1. T8 is 12. T9 is 1. What do you notice, Princess? What do we notice? That every odd term is 1. Exactly. So that means the 99th term, or the 999th term, because that is an odd number, our T999 needs to equal 1. Got it. Lovely. Amazing stuff. All right. So we can tell already by doing that, that T999 is going to equal 1. Easy stuff. We're done with that. The difficult one is going to be T1000. Okay. All right, but now the first one is easy. T999, easy enough. We can just tell by looking at it that it's going to be 1. T1000, we can't just look at and assume that it's going to be, that particular number. But now, let's venture to think about this in this particular way. All right, I know that every odd number in my sequence is 1. So technically what I'm looking at is not one sequence. I'm looking at 2 sequences inside one sequence. Thumbs up. Does everybody understand what ma'am is saying? Yes? I'm looking at 2 sequences inside one sequence. So to make my life easier, what would be the easiest thing to do in order to see the other sequence better? What would be the thing to do here? Okay, count in threes, yes. Or because there are two sequences in one, can I not just get rid of one of the sequences? Would that not be easier? Which sequence can I get rid of? In those two sequences, correct. Let's get rid of the ones, right? Let's just get rid of all the ones. That's it, Narisha, exactly. So what we're going to do is we're going to get rid of all the ones. But what does that do to my sequence? If I'm going to the 1000th term and I remove every second term or every second term, how many terms do I actually want? Or how many terms am I actually looking for? I'm not looking at 1,000 anymore. How many terms am I looking at? Not double. Are we confused? That's it, Sanele, correct. Okay, Princess, do you understand why Sanele says 500 instead of double? No? Okay, let's do it in tandem. All right, so let's look at this particular sequence the way that we're looking at it over here. Let me just see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'll stop there. All right, so if I write out this sequence like this, I go 1, 3, 1, 6, 1, 9, 1, 12. Okay, now if I count these, I know that this is T1, T2, T3, T4, T5, T6, T7, T8. So I have 8 terms here in front of me, right? But now if I take out all the ones, and I write just the sequence 3, 6, 9, 12. How many terms do I have now? I've got 1, 2, 3, 4 terms. I started with 8 terms. Now that I've taken out all the ones, I've got 4 terms left. Do you see it? Aha, there it is. And so we need to halve it. So instead of us using this particular sequence to look for the 1000th term, instead of looking for T1000, we're going to look for T500. Okay, and that's your job now, grade 10s. Find me T500, because once we've got T500, we're going to end up at T1000 anyway. All right, so first you need to find me a common difference. You need to find me the first term. You need to find me Tn, and then use Tn to find T500, please. Okay, pop your answer in the chat when you're ready. Anybody got an answer for me yet? Okay, I'm going to have a look at the answer. Otherwise, we're going to run out of time. All right. Okay. So I'm going to use this sequence that we've got over here. Okay. I know that my common difference, D, is equal to 3. My A is also 3. So Tn is equal to 3 plus open bracket n minus 1 multiplied by 3. Distribute n. So we'll end up with Tn is equal to 3 plus 3n minus 3. I know that the 3 and the negative 3 will cancel each other out. Therefore, Tn is just equal to 3n. Okay, and now I know that I'm looking for T1000, so I can just look for T500 instead, and it will give me the correct answer, which is 1,500. How many of us managed? Did we get it? Yes, 1,500. Well done. Hey, lovely stuff. All right. Shall we put a little bit more spice on it? Yes. Okay, let's see how many of us remember how to do these kind of questions. Okay. Ooh. Sorry, guys, my computer's frozen. I don't know what's going on. Ilani's brain is still on holiday. Oh, Auntie, so I'm sorry. Okay. Do we know where we went wrong? Oh, Princess says, ma'am, why is A3 if first term? Okay, remember, because we took out all the ones, Princess. Because we took out all the ones, that also changes what term 1 is going to be. Does that make sense? Okay, so term 1 can no longer be 1 in this smaller sequence. It needs to be the first term without the ones in it. Okay. Lovely. All right. Okay, so let's look at this question. I wonder how many of us remember how to answer this particular question. Okay, it says, find the fourth term of a geometric sequence whose third term is 18 and whose sixth term is 486. Anybody remember? How do we tackle such a question? How do we start? And this one not in grade 10. In grade 11 and 12, yes, but not in grade 10. Okay, that's it. Good. Asanda remembered spectacularly. Simultaneous, or however we want to label it, simultaneous, whatever it is. Yes, correct. But Sanele, this is not an arithmetic sequence. The GS stands for geometric sequence. Okay, GS stands for geometric sequence. So we cannot minus. What do we need to do instead of minusing, Sanele? What do we have to do? Not multiply. Not multiply. Almost, Didimalo. Not add. Now we're just guessing. We make equal to 0. No. We divide. That's correct. All right. Remember, you need to set up your two equations and then start from there. Remember, the one with the biggest, with the bigger number is always first, right? So we'll start with T6. T6 something 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 must equal 486 ... equation 1. And then we'll do T3. Something 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 is equal to 18 ... equation 2. All right, and that's far as I'm going to go. I'm going to add in here Tn is equal to a times r to the power of n minus 1, and I'll give you guys a chance to fill in the blanks. Okay. Sanela completely forgot. Well, I'm reminding you, this is the refresher that you needed. Lerato, do you need my help? Should I step in and help you with the rest of it? Okay. All right. Okay. So let's just remember. Okay. So remember, this 486 stands for the Tn part. So we've replaced the Tn part, which means this other part over here is what we need to put in this open space over here. All right. So that's what we're going to put in there. Now, we don't know what A is. We don't know what r is. The only thing we do know is what n is. We know that n is equal to 6. So over here, we're going to write a times r to the power of, our n is 6. So we'll have 6 minus 1. 6 minus 1. All right. And that's that first part. In this next one, we know that we've replaced n with 3. So we're going to have a times r to the power of 3 minus 1. Everybody still with me? We're still okay? Yes, thumbs up? Okay, lovely. Let's clean this up. Let's clean it up a little bit. So I'm going to take my equation 1, and I'm going to rewrite it as a times r to the power of. Now, 6 minus 1 will give me r to the power of 5 is equal to 486. And my equation 2 would read a times r to the power of 3 minus 1 will give us 2. So r to the power of 2 is equal to 18. But remember, this is a geometric sequence, and we're trying to find r. And the way we find our common ratio is by dividing. So our instruction for our simultaneous equation will say equation 1 divided by equation 2. And we can divide them in this direction even. All right, so a divided by a, those two will cancel each other out, right? R to the power of 5 divided by r to the power of 2 will give us r to the power of 3 is equal to, somebody punch into their calculator, 486 divided by 18. Yes, Narisha, exactly. That's why we come here. Okay. With the English. 27. Lovely, Princess. Thank you. So 486 divided by 18 will give us 27. We can already tell we want r, so we'll take the cube root on each side. Therefore, our r, our common ratio, is equal to 3. Everybody okay with how we got here? Yes? All good? Lovely. That gives us half the picture, by the way. It doesn't give us the full picture. Let's go put the rest of the picture together. So now I know what r is. So I can go Tn is equal to a times, I know what r is, 3 to the power of n minus 1. I now need to find a. And if I want to find a, let me just rewrite this nicely. I don't like the way I wrote it. A times 3 to the power of n minus 1. If I want to find a, I can substitute any of these two, because over here, I know that my n is equal to 3 and my Tn is equal to 18. So I can go in here and I can substitute that point there. So I can write here, sub in T3 is equal to 18. I hope I'm not losing anybody. Thumbs up. Does everybody understand what ma'am is doing here? Yes? Thumbs down if I need to explain again. I'm happy to explain again. All right. So I'm just going to take one of them. You could even choose T6 is equal to 483. It's going to work. We just need to pick one. All right. So I'm going to go in here and I'm going to replace Tn with 18. And I'm going to replace n with 3. So I'm going to have 18 equals a times 3 to the power of 3 minus 1. To the power of 3 minus 1. So 18 is equal to a times 3 minus 1 is equal to 2. So I know that this part is 2. That's 3 squared. 3 squared is 9. I want a on its own, so I'm going to divide this side by 9, divide this side by 9. Cancel, cancel. And therefore, a would equal 2. Okay. So we can put that together. We're not quite done. So we'll get Tn is equal to 2 times 3 to the power of n minus 1. All right. Thumbs up. Everybody okay? Are we all okay, peeps? Did we see what ma'am did there? Okay. It's quite the process, but we've got to remember it. Lovely. But we're not done. One more step. Zoom out. When you say zoom out, do you mean you want to see everything? Or can you not see everything? Guys, just give me a thumbs up. Are you able to see everything I've written on the screen so far? I think I've zoomed out properly. Sanali, you might need to check if you can't, because literally everything I've been saying is sitting on the screen at the very moment. So maybe check if you need to zoom in or zoom out in order to get what you need. Okay. All right. There we go. All right. So remember, guys, the question didn't actually ask us for the general formula. The question asked us for the fourth term. It asked us for the fourth term. So now that we've got the general term, we can now calculate for T4. T4 is equal to 2 times 3 to the power of 4 minus 1. And if you punch that into a calculator, you should get 54 as an answer. T4 is equal to 54. Okay, how did that feel? Good, bad? Give me an emoji. All right. Okay. Can I give you another one of these questions to screenshot so that you guys can go try it? I'm not going to give you the chance to try it now. The reason for that is because I want us to try something a little bit more challenging. Okay. Here's another one that you guys can go and try. Okay. Paste. Okay, so this one here says, find the arithmetic sequence. So AS stands for arithmetic sequence. Arithmetic sequence whose third term is 4 and whose 10th term is 28. Now, in this particular case, because it is an arithmetic sequence, instead of dividing, what are we going to do with our two simultaneous equations? How do we find the common difference? That's it, princess. We will subtract. We will minus one from the other in order to get what we need. All right. Okay, so go try that one. I want us to look at something a little bit more iffy. Okay. Okay, this one is a bit of a tough one, I will admit, but I want us to learn the technique rather than look at the question as something too challenging for us. Okay. Okay, I think we've done this one before, but I'd like us to just reiterate it again. All right, so the new curse technique, no, not quite, not quite. All right, so this question here says, find the values of K if the following terms are in arithmetic sequence. All right, so in this particular case, we know that they're in arithmetic sequence, and we know that this is term 1, this is term 2, and this is term 3. Now, we could try and find a common difference, but we're not going to be able to find one. We know that we need a common difference because this is an arithmetic sequence, but we're not going to be able to use it in any way because we're not going to get the same common difference. All right, let me explain. If we had to look for the common difference, remember the formula for common difference would be T2 minus T1 must equal T3 minus T2. Now, if I take just the T2 minus T1 part, I'm going to get K squared minus 6 minus, in brackets, K minus 1. And that's going to give me K squared minus 6 minus K plus 1. And that's going to give me K squared minus K minus 5. All right, that doesn't help me. Because if I do the other part, if I take T3 minus T2, I'm going to end up with 4K plus 1 minus K squared minus 6. And that's going to give me 4K plus 1 minus K squared plus 6. If I clean that up, that's going to give me negative K squared plus 4K plus 7. Now, these two things are not a common difference. Are we all in agreement that those two things are not common? Remember, a common difference must give us the same thing. It must give us the same thing. So we can't use either of those as our common difference. But what we do know is that these two things must be equal to each other. That's what we know. that they must be equal to each other? Thumbs up. Am I making sense? Does everybody understand what I mean when I say they must be equal to each other? Right? It's almost like if we had a simple formula, like if we had a simple sequence, like let's say, for instance, 4, 7, 10, 13, right? I know that T2 minus T1, which is 7 minus 4, which is equal to 3, must be equal to 10 minus 7, which is also 3. These two things must be equal to each other. So what I now can do is I can take these two equations and make them equal to each other. All right, so I'm going to say T2 minus T1 must equal T3 minus T2. That means K squared minus 4 or minus K minus 5 must equal negative K squared plus 4K plus 7. What am I solving for now, grade 10s? Ma'am, if they were the same, would it be yes, it would be a common difference. That's correct, and Andiswa, yes. If they were the same, we would punch that into a common difference. All right, this is basic algebra. I'm going to give you guys about 4 or 5 minutes to find me K. But we can already tell by that K squared that we're going to have a quadratic. Somewhere, somehow, something is going to have to give. Okay, we're going to get 2 different answers. And that's why the question specifically says the values and not just the value. The question says the values of K that we're going to get. So please find me those 2 values of K. You can pop your answer in the chat when you're ready. Yes, Andy, so but we should be able to factorize. It should be factorizable. Check again. Check again. You've missed something quite important. That's it. Okay. Princess, I'm not sure about both of them being negative. Let's check again. All right. Shall we have a look at the answer, grade 10s? Okay, so I know that I've got a quadratic, so everything's going to come over to that side. I'm going to pull everything over to that side. I'm going to end up with K squared minus K minus 5 plus K squared minus 4K minus 7 equals 0. So K squared plus K squared will give me 2K squared. Negative K minus 4 will give me minus 5K. Negative 5 minus 7 will give us minus 12 is equal to 0. All right, so some of the answers I'm seeing, I'm not sure if we're getting the correct answers here. Okay, so I should get a 2K and I should get a K somewhere. Okay, let's see if this thing, it should factorize. I hope. Factors of 4, 4 minus 3. So 4 here and 3 there. -8 plus 3 is equal to -5. Therefore, K must equal -3 over 2, or K must equal 4. Okay, and this is something we can do on a calculator. All right. So, show of hands, how many of us were dribbled by the maths here? How many of us were like, ish, I've forgotten how to do basic algebra? Because it happens. Remember, the last time you did something this complicated was term 1, or factorize something that didn't have a coefficient of 1 in term 1. It's been a while. It's been a while. Okay. All right. Sorry, guys. Oh, no gift. We're not doing that. All right, peeps. I'm going to end today's lesson here, but I want us to end with one particular question that I'd really like you guys to have a look at. Okay. I want us to have a look at this question over here. It looks very complicated. It does. But I'm going to walk you through how we can look at what these particular questions look like. All right. Let's talk about what we've been given here. It says, an arithmetic and a geometric sequence are combined to form the following pattern. So we've got x, 1 over 3, 2x, 1 over 9, 3x, 1 over 27. Okay, so we can tell just by looking at it. Yes, Andy, so this is the kind of example. I will give you a screenshot. Oh, you know what? I will add them to the Google Classroom so you can try some of the others out. Okay. All right. Okay. So let's look at what we've been given here. All right. So that's 1 over 3. And I meant to change the color, and I just didn't change the color. All right. So if we look at the two sequences that we've been given, because we have been given two sequences, which one of these is arithmetic and which one is geometric? Which one is arithmetic? The purple one or the pink one? Which one is arithmetic? The pink one, okay. Why, Didimala? Why do we say the pink one? Common difference, okay. So we can look for a common difference. So if we take the pink one, let's take the pink one and see. If we take the pink one, if I have to have a common difference, 1 over 9 minus 1 over 3 would actually give me -2 over 9, -2 over 9. And 1 over 27 minus 1 over 9 would give me, I would need 3 over there, would give me -2 over 27 and not -2 over 9. So I don't think that the pink one is an arithmetic sequence. Okay. So obviously it's going to be the purple one. But look at the purple one. What is the common difference? What is the common difference? It can't be 1. Be a little bit more specific. That's it, Didi Malo. Lovely. It's 1x. Let's look at it in detail, right? I've got x, and then I've got 2x, and then I've got 3x. Okay, so I can tell that the difference between 3x and 2x is x. The difference between 2x and x is x. So my arithmetic sequence is the purple one, and my geometric sequence would then have to be the pink one. So we can try this out. 1 over 9 divided by 1 over 3 is going to equal to 1 over 3. 1 over 27 divided by 1 over 9 is going to equal 1 over 3. So we know that the pink one is our geometric sequence. All right. The first question says, write down the next 2 terms of the sequence. So I see purple, pink, purple, pink, purple, pink. So I know that the next number here or the next term needs to be purple. What is that number that goes in there? What is the term? That's it, Narisha. Lovely. It's 4x. Right, it's 4x. So I know that my next term is 4x. Then we need to find the purple part, right? Oh, sorry, the pink, the next pink one. Now, I know how I got from one answer to the other. I multiplied. 1/3 times 1/3 gives me 1/9. And 1/9 times 1/3 gives me 1/27. So to get from the next one to that one over there, what is that answer going to be, guys? What's the next pink part going to be? One over 81. And I assume that's what you meant, Asanda, rather than 31. We meant 1 over 81. Right. So we'd multiply by 1/3, and we should get 1 over 81 as an answer. Okay. Then the next question then says, determine the general term for the odd terms of the sequence. So the odd terms. If we look at the odd terms, this x is my t1, that one is t2, 1/3 is t2, that is t3, not t3, t4, t5, t6, t7. So when they say determine the general term for the odd terms, they want us to find the general term for the arithmetic sequence. And it says, write down your answer in terms of x, because we know that x is going to be part of this answer. Okay, we know that x needs to be part of our answer because x is part of our common term or our common difference. So we can use Tn is equal to a plus n minus 1 common, open bracket, d. All right, so let's talk about what we have over here. We know that our a is going to be our first term, that's x. We know that our common difference, we calculated our common difference was also x. So we know we have x and x. So let's go ahead and put this into the formula. So we'll go Tn is equal to x plus, open brackets, n minus 1 multiplied by x. Okay, let's distribute out. Okay, if we distribute, okay, we're going to end up with Tn is equal to x plus n times x will give me nx, -1 times x is -x. So these two will cancel each other out. X minus x is nothing. And then we'll have Tn is equal to nx. Thumbs up. Everybody okay with what ma'am has done here? Are we all good? Yes, I'm hoping that we're okay. Okay, all right. Let's look at question 2.3. Okay, 2.2.3 says, calculate the value of P26. Which one is that? Which one is P26? Is that the arithmetic or the geometric sequence? P26. Think about the way that they've structured each of these. Okay, the question above, that's it. It's the pink. The question above asked us for the odd terms, and we've managed the odd terms, but now they want P26. P26 is the even terms. So if we want to figure out P26, we first need to figure out the common ratio, and we need to put together our Tn. All right. So we're then going to say Tn is equal to a times r to the power of n minus 1. Now remember, our first term is going to be the first pink term, right? But remember what we did with that other question before. If I now decide to take away the arithmetic sequence, so if I take this away and this away and that, and we continue taking all of these purple ones away, I'm not actually looking for P26. Which term am I actually looking for? It's not 26 anymore. Beautiful princess. Absolutely. I'm looking for P13. Does everybody understand what we mean there? Yes, if we take away each of the second one of each, we're going to end up with P13. All right, so please, guys, calculate for P13 for me. Let's punch in the values that we've got here. We'll say T13 or P13, it won't make a difference, is equal to our A value is 1/3 multiplied by our common ratio, which was also 1/3 to the power of 13 minus 1. And we can punch that into a calculator. Somebody please give us an answer. I just can't see my calculator. I'm sitting in the dark. So I need somebody else to help me, please. It should be an ugly answer. It should be very ugly. That's it. Yes, correct. It should be that ugly. It should be a big number. Yes. So 1/159, 1594323. That is spot on. 4323. Well done, my darling. That's perfect. Guys, do you want to know something a little scary? Can I tell you guys something scary? Yes? Do not round up. Do not round off. Okay. Do not round up, Fulani. You always leave the answer